Welcome back, learners. I'm Chongtham David, your mentor, and in this 11th episode of our Neet Chemistry series for 2025 and 2026, we are diving into the electrifying world of electrochemistry. This topic isn't just about equations and chemical reactions, it's about understanding the flow of electrons that powers everything from the batteries to the biological processes. We shall tackle 45 carefully selected questions that will illuminate concepts like redox reactions, galvanic cells, and electrode potentials. Remember, as Michael Faraday once said, nothing is too wonderful to be true if it is consistent with the laws of nature. Let's harness that wonder as we explore the current that drive all these chemical chains. So let's get charged up and spark our understanding of electrochemistry. Now, without any further ado, I'm going to share the screen. Let us read the first question. Question number one. A gas X at 1 atmosphere is bubbled through a solution containing a mixture of 1 molar Y minus and 1 molar Z minus. At 25 degrees Celsius, if the reduction potential of Z greater than Y greater than X, then which of the following is the correct answer? So this is the question. Now, after analyzing this question thoroughly, the given order of reduction potentials or the tendency is given as Z greater than Y greater than X. Now, a spontaneous reaction will have the following characteristics. Z reduce and Y is oxidized. Z reduce and X is oxidized. Y is reduced and X is oxidized, as evident from this descending order. So Y will oxidize X and not Z. So option A, Y will oxidize X and not Z, is the correct answer for question number one. So I hope it is understood. Let us move on to the next question, question number two. On the basis of the following E naught values, the strongest oxidizing agent is. You are given a reaction here, iron 2 changing to iron 3 by losing of electron. Now cell potentials are given here, and in the second case, this iron is changing to Fe2 is changing to Fe3 plus, that it is also undergoing reduction, same oxidation, same process. But these SRP values are different. Now, on these values, question is asking you what is the strongest oxidizing agent. From the given data, we find that this ferric is strongest oxidizing agent. Remember, more the positive value of E naught, more is a tendency to get oxidized. Thus, the correct option is good, option C. I hope it is clear. Let us move on to the next question. Question number three. The resistance, here the options are not given. Anyway, let us calculate the question first, then later on the answer will be automatically okay. Let us read the question. Resistance of a conductivity cell filled with a solution of an electrolyte of concentration zero point 0.1 molar is 100 ohm. The conductivity of this solution is 1.29 Simon meter inverse. Resistance of the same cell when filled with zero point 0.2 molar of the same solution is 520 ohm. The molar conductivity of zero point 0.2 molar solution of the electrolyte will be. So you know the formula resistance, and resistance is given to you as 100 ohm. Now conductivity I can relate as 1 by resistance, cell constant is L by A. Now this is given to you, that is 1.29. I hope it is visible here, right? 1.29 Simon meter inverse. So now what you have to do here is you find out the value of molar conductivity. How can it relate? It is related as kappa conductivity into volume. And this kappa can be calculated as from this initial relation 1 by R L by A, which is also known as the cell constant. So if I substitute these values here, mu equals to kappa 1 by resistance. Okay, let me shorten the equation given here. 1 by resistance into cell constant is your kappa conductivity, right? So resistance is 520 into what is the cell constant given to you here? 129 multiplied with this volume, that is 1000 divided by 0.2, right? Now, if you calculate, the answer would be approximately, but you need to do here one conversion here, because you need to convert this to meter cube, minus 6 meter cube. Okay, I hope it is clear. So the answer would be approximately, cancel this, 12.4 10 to the power minus 4 Simon meter square mole inverse. So find out the answer from this given option. You have already calculated molar conductivity as 12.4 into 10 to the power minus 4. Let us see whether there is any option in the given question. 12.4 into 10 to the power minus 4. Yes, the option is there in question number, option number B. 12.4 into 10 to the power minus 4. This is the answer to question number 3. Moving on to next question, question number 4. Let us read. For the electrochemical cell given here, this double bar is your Soul bridge. Now, cell potential, the standard cell potential for this metal ion is 0.44, and this X is given as 0.33. From this data, one can deduce the following. What is the correct answer for this? Let us decode the answer by first writing the reaction. See, whatever that is on the left side is your anode, and whatever that is on the right side of the this salt bridge is your cathode. And in anode there is oxidation, cathode there is reduction. Remember that point, and never forget, whenever there is increase in the oxidation number, that corresponds to oxidation, and if there is decrease in the oxidation number, that is your reduction, and reduction is your oxidizing agent, and the one which undergoes oxidation is your reducing agent. We also call it reductant. Now, cell potential can be found out from the relation E cathode minus E anode. I hope this is clear. Point 11, right? So this is a spontaneous process, because this E naught cell values comes out to be a positive quantity. You know the relation delta G and E, right? So to find a reaction whether it is spontaneous or not, delta G must be negative, right? So to be negative, E naught must be positive. So to be spontaneous, just remember the formula minus NFE cell, which means this is a spontaneous reaction, and E naught has to be positive quantity to be a spontaneous. So from this option available to you, we can say that this is the correct answer. B is the answer to question number 4. Right? I hope that is understood. Let us move on to the next question. Question number 5. What will be the EMF for the given cell? It is just you're using standard hydrogen electrode by using this platinum in terms of pressure. Okay, same concept, but we know that already that this hydrogen has a standard cell potential of 0 voltage. So whatever that is on the right hand side will undergo oxidation. That is the uh, this is your anode, and here on the left hand side it is your cathode, where reduction takes place. So on the right hand side, that is on this side, we have your cathode. Remember the rule of the thumb, red cat, which means cathode is where reduction takes place, and ox, that means oxidation takes place at the anode. And on the left side, it is your anode, where oxidation takes place. Now, let us see the reaction that might take place on the right hand side, where right hand side is your cathode, reduction takes place. Now, let us build up this half cell reaction. For this question number 5, this proton should gain an electron, because on the right side, what have I said? There is reduction process. So it maintains an equilibrium, and hydrogen ion gets reduced to hydrogen molecule. Okay, the pressure given to you is P2, and on the left hand side, you have hydrogen at pressure 1. So this is going to undergo oxidation. By losing electrons, there is oxidation. So overall reaction, you can find out what is the overall reaction. H2P1 should, you can easily cancel these electrons later on, okay? If you know it, just keep it. Okay, I have to erase this. It's becoming quite bigger, right? Okay, yes. So this hydrogen P1 should now change to hydrogen at P2. So this is the overall reaction. Overall reaction. I have done a mistake here. Let me erase this. H2P1 should now be at H2P2. Okay. So for this question, when you calculate the EMF, it would be in the sum RT. Two electrons are involved. Log of, which is your anode. Anode is your, okay, P1 by P2. I hope this is clear. Question number 5, option B. Moving on to the next question, question number 6. What is the standard cell potential E0 for an electrochemical cell in which the following reaction takes place spontaneously? So I have already explained before, the condition for spontaneity is delta G should be negative quantity minus NFE. That means it proceeds in the forward direction. So the standard cell potential has to be a positive quantity, right? So delta G naught by NF, substitute the values, it becomes minus of 50.6 joule divided by 2. This is the number of electrons involved in the reaction. Faraday constant. You should know this Faraday constant is derived from the multiplication of 1 mole, this Avogadro's number, and the charge of an electron, which is 96,500. Now multiply again with 10 to the power minus 3 to convert into the proper values. Simplify this. You can get the answer. 0.26 volt would be the answer for question number 6. So I hope this is understood. Let us move on to the next question. Question number 7. The unit of equivalent conductivity is. So equivalent conductivity is ohm inverse centimeter square gram equivalent inverse. So option B is the answer to question number 7. Clear? Let's read question number 8. The variation of equivalent conductance of strong electrolyte with the concentration. Actually, this is based from your Debye-Huckel's equation. So in case of equivalent conductance of strong electrolyte, there is little increase with the dilution. So A would be the answer to question number 8. This is your theory-based question. Moving on to next question number 9. Consider the following cell reaction. Iron is changing to iron 2 plus, and given cell standard potential is 1.67. So here the number of electron is equals to how much? 4. The change in the number of electrons you can calculate here, gives n equals to 4. Multiply this, okay? You are going to get the value of change in the number of electrons. And according to the Nernst equation, what is Nernst equation? This is an equation to find cell potential whenever there is change in concentration or temperature. So E equals to A naught minus 0.0591 divided by N, which is a general formula which I've learned in your 12th standard. So remember this formula. This is going to be very important for your NEET exam. Okay, and not by cathode. So whatever concentration that is present, you can write it here and substitute the values. What is the standard cell potential according to the given question? 1.67. I hope you can see this one, right? So subtract this 0.0591. What is the total number of electrons that is involved here? I have already explained before. That is 4. Then multiplied with log concentration of iron given to you is already, yes, 10 to the power minus 3, right? This one. Yeah. Then substitute again the value of this hydrogen ion concentration. The 10 to the power minus, sorry, this should be partial pressure of oxygen. So what is the given value for this oxygen? Hydrogen you have already given 10 to the power minus 3, then raised to the power 4. The stoichiometric coefficient involved in the equation should be 4. And the pressure of this oxygen is 0.1. Now you have to simplify this equation and you can easily get the answer. 1.67 minus 0.0591 divided by 4. So what would be the answer for this entire term? The value for this log would be 14 will raise to the power as plus, and this 0.1 also, if it is added, 14, 13, right? So 13 and 3, after simplification, okay, this becomes 1 point log 10 to the power, this would be approximately 7, then 1.67 minus 0.103 after subtracting approximately 1.5. Get it? So D is the answer to question number 9. Good. Let's move on to question number 10. The electrical properties and their respective SI units are given below. Identify the wrongly matched pair. Now this cell constant is L by A. Unit should be, what is the value of L by A? Meter by meter square. So meter inverse. So this is wrong. D is the answer to question number 10. Moving on to the next question, question number 11. Limiting molar conductivity of ammonium hydroxide. This is based on your Kohlrausch law. Okay, so you're given ammonium chloride. If I dissociate this, okay, in general, you just write that all these are strong electrolytes. Strong electrolytes completely dissociate in the solution, and the degree of dissociation is unity. Now we need to find this limiting molar of ammonium hydroxide. So if I dissociate this ammonium hydroxide, I will be getting molar conductance at infinite dilution for this respective ions. Ammonium hydroxide is a weak electrolyte, and Kohlrausch law is based on weak electrolytes. It is a method to determine the molar conductivity at infinite dilution for weak electrolytes. So if I link up with another strong ions, I should be able to find out this molar conductance of weak electrolyte ammonium hydroxide. So ammonium, if I link this with chlorine or chloride ion, this becomes ammonium chloride, which is a strong electrolyte. So initially what is not there, if you add it, later on you have to subtract it. This is the basic principle of Euclid's lemma, right? Whatever that is not there in the system, if you add it, later on you have to subtract it automatically. Anyway, moving on to the question, let us come to the question. What we have here is hydroxide. Now if I compare this sodium, if I link this with hydroxide, I'm basically pairing this up. Sodium hydroxide is a strong electrolyte, ammonium chloride is a strong electrolyte, but this chloride and sodium is not present initially according to this first equation, so you need to remove them again. Okay, because whatever that is not there, you have to remove them again after carrying out the process. So this is the basic idea, okay, for calculation. So sodium we have added, which was not present, you have to subtract it again. Chloride, which was not added, was not present, you have to subtract it again. So all these are becoming the strong electrolyte. Okay, so this is the idea behind the question. So the first option is not the correct answer because sodium chloride is going to get a negative quantity. So the answer would be ammonium chloride plus sodium hydroxide negative sodium chloride. Let us see the remaining options for question number 11. Yes, B, C, and D. So D is the correct answer because it matches with what we have just calculated. I hope it is understood. Question number 12. A lead battery containing 5 liter non-normal sulfuric acid solution is operated for 9.65 into 10 to the power 5 pentasecond with a steady current of 100 milliampere. Assume volume of the solution remaining constant, normality of sulfuric acid would be. So basically, this is the general principle you have to obey. So what we have to consider here is the number of electrons that is involved. So in your theory part, you have already learned the overall reaction. I need not write the individual reaction, that this lead and lead oxide in this sulfuric acid reacts in such a way to get this overall reaction. This is the charging reaction. Now, number of electron involved is 2. So 2 Faraday coulomb is consumed during this entire process. Okay, and this 2 into Faraday constant consume how many equivalent of sulfuric acid? This one. Yes, so 2 Faraday coulomb is consumed during 4 equivalent of sulfuric acid, and 100 milli ampere is given to you. You need to multiply this with 9.65 10 to the power 5. I'm simplifying this Avogadro's, sorry, this Faraday's constant here. Now, you are given this much of milliampere and it is operated in 9.65 10 to the power 5 second. These are the given values of current. So how much current it will be consumed? Let us calculate 4 into 100 into 10 to the power minus 3, 9.6. This is simply your unitary method, 10 to the power 5 divided by 2 times 96,500. So this gives, after cancellation, you can cancel all this, okay? Cancel by 2, you're getting 2 equivalent of sulfuric acid. So there is a decrease in the normality. Initially you have 5 liter, so now you have only 2. So 2 equivalent means there's a decrease by a factor of 2 by 5 values. So 2 by 5 value is nothing but 0.40. So D would be the answer for this question. It is a concept question based on Faraday's law and battery. Now let us read question number 13. The electrode potential of zinc zinc electrode at room temperature with aqueous solution of 0.1 molar zinc sulfate is. So for this question, same concept we have done before. You apply the Corral's law. The Nernst equation. So let us write. Nernst equation for this reaction would be, this is the standard. Okay, anything that is known to you is called standard, be it temperature, be it pressure, anything with known quantity at standard condition, we call it. So log anode, or you can say metal by metal ion, which is your basic Nernst equation. Substitute the value and you can easily get the answer from this. It's not difficult, right? Okay, the answer, let us calculate. What is the value of N2? Log of 1 by 0.1. So it gives same point, standard value is 0.76 and 0.03. So if you add this, you get approximately 0.79 volt. What is the answer for this question? B. I hope it is understood. Good. Let's move on to question number 14. A battery is constructed of chromium and sodium chromate. The unbalanced chemical equation when such a battery discharges is as follows. If 1 Faraday of electricity is passed through the battery during charging, the number of moles of chromium ion removed from the solution would be. So let us try to build up the reaction, the half cell reaction, to understand it much better. So reduction half reaction. If you would write the reduction half reaction, this Na2Cr2O7 would generate dichromate ion. This would gain electron in acidic medium and form chromium. To balance this, we are adding water molecule. Now, the other half reaction, let me write it here. There is no space, so I hope it's visible. Oxidation, okay, that is the losing of electrons. Chromium losing 3 electrons. So you can add these two equations. The overall redox reaction would be, yes, this given equation. So if I balance this equation, I would be getting a 14 hydrogen ion and 3 electron, 3 chromium to balance this, and 7, right? And this sodium ion will not be present because these are cancelled already with this sodium, and this becomes an ion. So let me erase this part. The sodium will not be in the overall ionic reaction. So you can see that there are 3 electrons, right? So 3 electrons corresponds to 3 Faraday of electricity, right? 3 Faraday of electricity is equivalent to how many moles of chromium ion? 3 moles of chromium ion. So basically you have 3 moles of chromium ion generated from 3 Faraday of electricity. So for one, by using unitary method, what would be the answer? 1 Faraday of electricity would be definitely 1 mole. Cancel this, you get 1 mole. Okay, 3 by 3 or 1. So there is no 1 mole, so we'll simply write 3 by 3. This is the answer to question number 14. I hope it is understood. Let's move on to the next question, question number 15. Which of the following reaction is possible at the anode? It would be A. This is the answer for question number 15. It's easy because the oxidation state of chromium changes from +3 to +6 by the loss of electrons. At anode, oxidation takes place, right? Moving on to the next question, number 16. In a hydrogen oxygen fuel, combustion of hydrogen occurs due to, right? So in hydrogen oxygen fuel cell, the combustion of the, remember this fuel cell is particularly mentioned clearly in your syllabus, so you need to read this. Now, the combustion of this hydrogen occurs to create a potential difference between the two electrodes. This is the basic idea for these fuel cells. So question number 16, the answer would be B. Let's read question number 17. The standard reduction potential for this given equation. Okay, this is your cell notation, and copper is given 1.10 at room temperature, that is 25 degrees Celsius. Equilibrium constant for the reaction. You need to know the formula. I'll give you the formula here. A very important formula. You need to remember this. To solve equilibrium constant divided by this is the number of electrons that is involved here. So we have 2 log of equilibrium constant Kc. Find the answer from this. You're going to get, let us see. If I substitute the value of this cell potential is 1.1 here, after cross multiplication, 2 divided by 0.05 log of Kc. Remember this log of Kc, you need to find the antilog. I have already made a short on antilog, how to find antilog without using any calculator, how to find antilog without using any table. I have made a short on that. You find in the section of shorts in my channel. Now, you find the nearest integer for this calculation, and your Kc would come to be equals to 1.9 into 10 to the power 37. This is the answer for question number 17. Option number B. Remember, you need to find the antilog. So for such case, you have to check out my, there's a video shorts created on a trick for antilog, finding of antilog without using any table. Let us see question number 18. The correct order of this standard potential values with negative sign for the 4 successive elements, chromium, manganese, iron, and cobalt, is as follows. So for this, the standard reduction potential values without considering the negative sign would be manganese, chromium, iron, and cobalt. So A would be the answer. You have to remember the electronegativity series, okay? Sorry, not electronegativity series, that electrochemical series. I can make a mnemonic here. Little kings cannot make a zebra. I like his car, silvery gate, right? Question number 19, the spontaneous reaction, the equilibrium constant and E naught shell will be respectively. This is also theory based question. It would be delta G would be negative and E cell would be positive. We have done this before. Moving on to the next question, number 20. If the cell potential for a given reaction has a negative value, then which of the following gives the correct relationship for the values of del G naught and EQ equilibrium? Okay, constant K. Now, standard gives free energy is given as delta G naught is minus NFE cell. If cell potential is less than zero, it means negative, and definitely your Gibbs energy will be greater than zero. And you have the relation, remember, Gibbs free energy is given as delta G naught, or you can say delta G, because at equilibrium G naught is already zero, right? 2.30, 3 RT log Kc. And if this Kc is 1, okay, delta G would be 0. When considering if Kc is less than 1. Now, if delta G is minus NF E cell must be positive to have delta G as negative value. So, looking at the question, what would be the answer for this question? The answer would be G naught would be greater than 0. Equilibrium constant would be less than 1. Let's read question number 21. Which of the following expressions correctly represent the equivalent conductance at infinite dilution of aluminum sulfate? You're given the molar conductance of aluminum and sulfate, right? So conductivity of an electrolyte depends on the mobility of ions and concentration of ions. You see, the motion of an ionic species in an electric field is retarded by the oppositely charged ions. It is due to the inter-ionic attraction. Okay, so by dilution, the concentration of electrolyte decreases and the retarding influence of the oppositely charged ions will definitely decrease. Then your mobility of ions will increase. So 21 would be C. Let's read question number 22. Given cell potential of chromium and permanganate, dichromate, and right from this cell potential values, you can easily answer the question. What is the strongest oxidizing agent? So higher the values of standard reduction potential or SRP, stronger is the oxidizing agent. So hence this permanganate would be the answer for question number 22. Let us see question number 23. The standard reduction electrode potentials of four metals ABCD, same question repeated again, minus 1.2, 0.6, 0.85, and 0.76. So from this, we can easily conclude C, B, D, and A, right? As the value of this reduction potential decreases, reducing power increases. So let us see for this option C, B, D, A, right? C, B, D, A. CBD. Where is it? CBDA. Yes, option C would be the answer for question number 23. Moving on to the next question, question number 24. Which of the following statement is correct? Read all the statement. 24. 1 is wrong. B, yes, this is correct. Then no, this is not the answer because based on the electrochemical series, this is not preferred. Zinc is not a reference electrode. Hydrogen is a reference electrode. So 24, the answer is B. Let's read question number 25. Molar ionic conductivities of the two bivalent electrolytes are 57 and 73. The molar conductivity of the solution formed by them will be. Now you have to add these two value and you can easily get the answer. What is the answer for this addition of 57 and 73? It be 130, right? So it is the answer. Option A. Question 26. The cell, okay, you are given here cell notation. This is allowed to be completely discharged at room temperature. Relative concentration of zinc with respect to copper, that is zinc ion by copper ion, is. How would you get the answer? By Nernst equation, we have, I'll shorten it. You have E cell equals to 0. And what is the value of E naught cell? Let me simplify Nernst equation here. 1.1 minus 0.0591. Number of electron involved is 2. Log of, yes, you need to find this. Right, so simplify this and you will get the answer. So let me write here on the bottom, log zinc ion by copper ion would be, yes, after simplification, you get 2, 1.1, 0.0591, approximately 37.3. So by using the method which I have taught, okay, you go and find out the video in the shorts, you will find that there is a section where you can easily determine anti-log values without the help of calculator or any log table. So now the question comes, how to find this? It would be anti-log of 37.3. So just erase this 37, okay, before, because it is in front of the decimal, right? 10 to the power 37. So what is the nearest answer for this question? 26. D. Moving on to the next question. Question number 27. Which of the following statement is true for an electrochemical cell? The reduction potential of copper is more than hydrogen. This is true. Question number 27, option C. 28, you're given different types of, this is reduction reactions, and you have standard reduction potential. Considering the electrode potential, which of the following represents the correct order of the reducing power? Remember, reducing character decreases down the series. Remember, electrochemical series ECS is very important for you to learn by heart. If possible, learn to by heart the values also for some common ions. Now, 28, aluminium will come first, then iron 2 plus, then Br minus. From this value also it is evident, right? So correct answer for question number 28 would be the aluminium, iron and bromine. Aluminium, then iron, then bromine. Because the most positive will be the most reducing in character. So most negative is aluminium followed by 0.77, which is lesser than 1.09. So aluminium, iron, bromine. D is the answer to question number 28. 29, let us read. Standard free energies of formation are given. Now this is for carbon dioxide, pentane, respectively. Water, okay, 237 is for water, 394 for carbon dioxide, 8.2 for pentane. What is the value for cell potential for pentane? This is a fuel cell again. Pentane, oxygen, hydrocarbon, oxygen, fuel cell. So you can find out from this relation to find this E naught value. Use the relation delta G is minus NFE cell. Okay. From this value, you are given here minus 338,700. Okay, how will you obtain this? Let me re-explain this again. Okay. The relationship is delta G equals to minus NFE naught cell. So what you have to do here, first you need to find this delta G naught overall value. Let me write here on the bottom. What you have to do here is write the overall reaction. You know what is pentane, right? C5H12 plus 8 oxygen gives carbon dioxide and water. So delta G naught can be found out. Okay, you have to multiply these values. This is for carbon dioxide, and this is for pentane, and this is for water, right? So delta G naught will be 5 times carbon dioxide is minus 394.4 plus For water, it is 6 times 273.2 minus, and for this 8.2 is for pentane. You have to just find for state of matter where there is gas. Okay, you don't find for liquids. So what would be the answer for this? It is minus 3387 kilojoule. So from this, you convert to joule. I will shorten the value here. Now you have already got 3387. Multiply with 1000, you will be obtaining 338700. A negative quantity comes here. And the total number of electrons is, it would be 32 electrons. Because in this, you have 8 to the 16, 16 to the 32, 32 electrons. Okay. From this equation, you have the value of N. Faraday's number is 96,500. Then E naught cell. You're about to determine this E naught cell. So E naught cell would be 33870. Multiply this 32 into 96,500. Where is this minus gone? It is cancelled. It has got cancelled. Okay. So you have now cancelled these zeros. You are going to get 3387 by, let us say, 308. So you find the approximate value, not overall. This part you can easily remove. 3 by 3 is approximately 1. Do the division. The value will be approximately 1.096. Like, you need not calculate the exact value. Okay. From the options, you can easily determine. That is one exam technique. Now, let us see question number 30. Given iron, okay, chromium and iron, their cell potential, and you have the cell notation. So question is asking you, what is this iron? The potential for this, the standard cell potential for iron. Okay. Now use Nernst equation again whenever there is change in concentration, because you have 0 0.1, 0 0.001. Don't always follow E cathode by E anode. That will not work in most of the case, because whenever there is change in concentration, never forget to use this Nernst equation. So to find the standard cell potential values, let us write the value 0.72 minus 0.05. Total number of electron would be, here you have, take the LCM when the numbers are not equal, 6. Log chromium is 0 0.1. Okay, after balancing, you would be getting here 2. For iron, you would be getting here 3. And if you simplify this, 0.3 minus 0.0596 log 10 to the power minus 2 by minus 6, right? Point, okay, 3. So if you simplify this, you will be getting 0.3 minus 0.059 by 6. So 4.3 minus 0.03. It would be approximately 0.26 volt. Good. So answer is option A. Let us see question number 31. Electrolysis of dilute sodium chloride solution was carried out by passing 10 milliampere current. The time required to liberate 0.01 mole of hydrogen gas at the cathode is. Okay, let us write the equation. Water, if it dissociates, it will definitely give you hydrogen ion and hydroxide ion. So, and this hydrogen ion can gain 1 electron and change to hydrogen molecule, but it is not balanced, so you have to write here half. So what does it indicate? 0.5 mole, half mole, okay, of hydrogen is liberated by passing 1 Faraday, that is 96,500 coulomb. So what would be for 0.01? Okay, for 0.01 mole of hydrogen, the gas it would be liberating how much charge that you have to follow by unitary method. All right, 0.5 into 0. This would be the answer. You have the charge approximately 1930 coulomb. What is the relation between time and charge and current? So now you have 1930 coulomb divided by how much milliampere? 10 milliampere. Milli means 10 to the power minus 3. So you do the math here, minus 2. If it comes in the numerator, it would be 19.3, 10 to the power 4. Option number B. Moving on to question number 32. Which of the following reaction occurs at the cathode during the charging of lead storage battery? It would be option number D. Okay, D is the answer. 33. Conductance of zero point 0.1 molar potassium chloride in a conductivity cell is Y ohm inverse. If the conductance of sodium hydroxide 0.1 molar concentration is filled in the same cell, that is Z ohm inverse, the molar conductance of sodium hydroxide will be. See, cell constant can be found out from this. Let us decode, okay? So it would be cell constant would be X by Y. And what is the conductivity of the sodium hydroxide? The conductivity of sodium hydroxide would be X by Y into this Z times, because this is a conductance, XY into Z. Now, what is the molar conductance for the sodium hydroxide? For sodium hydroxide, molar conductance, it would be X by Y times Z, and given to you is 1000. This is the volume divided by 0.1. So simplify this, xz by y, 10 to the power 4. The nearest option is B. This is the answer to question number 33. I hope that is understood. Let us read question number 34. How much charge is required when 1 mole of dichromate reduced to form 1 mole of chromium 3 plus 34? See, there is a total of 6 electrons. These 6 electrons are required to form 2 moles of chromium. You write the ionic equation and you're going to understand much clearer. So to form 1 mole of chromium, you require 6 electrons. That means 1 mole of chromium, 3 Faraday of charge would be required. So answer would be 3F. Question number 35. In electrolysis of dilute sulfuric acid using platinum electrodes. Okay. 35. When platinum electrodes are dipped in dilute solution, sulfuric acid, then hydrogen gas is going to be evolved at the cathode. So for question number 35, A would be the answer. I hope you're all keeping up with me so far. We are just left with 9 questions. Let us continue. You know, the secret of success is consistency. Moving on to this question, number 36. The resistance of 0.1 normal solution of salt is found to be 2.5 into 10 to the power 3 ohm. The equivalent conductance of the solution, the given cell constant, is 1.15 centimeter inverse. Now, specific conductance is, you remember this formula? Specific conductance is conductance multiplied with your cell constant, that is L by A. Clear? So specific conductance is your kappa, and conductance is 1 by resistance. So you're given resistance 2.5 in the 10 to the power 3, and cell constant is 1.15. So after calculation, you will be getting, all right. So find the equivalent conductance. You're going to get 1.15, 2.5, 10 to the power 3. So you have to divide this with volume. So it becomes 1000 divided by 0.1. Okay, so the answer would be 4. Yes, nearest value would be 4. So option A would be the answer to question number 36. I hope it is understood. The highest, question number 37, the highest electrical conductivity of the following aqueous solution is of. So this difluoroacetic acid, being the strongest acid, will furnish maximum number of ions showing highest electrical conductivity. and the decreasing acidic strength of the carboxylic acid will be such that difluoroacetic will be the highest, followed by fluoroacetic acid, chloroacetic acid, acetic acid, because you see this fluorine is the most electronegative element. It is linked to this acetic acid. Difluoroacetic acid would be the highest. So A would be the answer. And you remember this, all this concentration remain the same. So option A. 38. When during electrolysis of silver nitrate, 9650 coulomb of charge passing through the electrolyte electroplating bath. Okay, the mass of the silver deposited on the cathode. So this question number 38. So use the Faraday's law of electrolysis. How to answer this question 38? When during the electrolysis of, the options are given on the next slide. So let us first read the question thoroughly. When during electrolysis of a solution of silver nitrate, 9650 coulombs of charge is passed through. Remember 9650 coulombs. Okay, the mass of the silver deposited on the cathode. So number of moles of silver would be, you can find weight by molecular mass, or you can simply write by Faraday's constant 96,500. This would give rise to 0.1 moles. So what is the mass of silver going to be deposited? 1 by 10 times this atomic mass. You know, atomic mass of silver is approximately 107.9, right? So round it off and enter it 10.8. Option A is the answer to this question number 38. Let's see question number 39. The reduction potential of hydrogen half cell will be negative if. Okay, so to calculate this question, you have to write the half cell reaction for this hydrogen. This is gaining of electron. It is gaining means reduction. Losing means oxidation. Now E cell equals E naught minus, you are going to use again the Nernst equation, 1 log of hydrogen. This was the equation that you have remembered, right? So raised to the power, the stoichiometric coefficient. Now if this partial pressure of hydrogen given to you is 2 atmosphere, how would I rewrite this equation? The new equation would be modified as E equals to, standard is given 0 at equilibrium, minus 0.059 by 1. This is the total number of electrons. See here, right? Okay, so 1 is the number of electron involved, log. We are considering the concentration as 2, pressure as 2. So if I would write here 1 by 2, 1, what is this value? Let's calculate 0. So it would be minus 0.05 by 2. Take out this log. What is log 2? 0.301. So answer would be a negative quantity, right? Will be negative. You need not calculate all this. Just find from this relation. 39 would be option number C. Moving on to the next question, number 40. When electric current is passed through acidified water, 112 ml of hydrogen gas at standard temperature pressure was collected at the cathode in 965 seconds. So what is the current pass in ampere? Now 112 ml of hydrogen at standard temperature pressure equals 2 into 112. This is the given volume here, okay? Divided by 22,400. Since this 22,400 ml at STP would be the molecular weight. Now amount deposited would be, you can find out from the relation, equivalent weight into current into time by Faraday's constant. So multiply this 112 from the above equation. Equivalent weight is 965 seconds into, you need to find current. Question is asking current by 96,500. So you can cancel this. What is the answer for this? 1 by 100, 100, right? Cancel this again. You can also cancel this. 224 is equals to 2 into 11. So current is 1 ampere. Option A is the answer to question number 40. I hope it is understood. Let's see question number 41. An electrolytic solution contains a solution of silver sulfate and has platinum electrodes. A current is passed until 1.6 gram of oxygen has been liberated at the anode. The amount of silver deposited at the cathode would be. So you can use Faraday's law, weight by equivalent weight, equivalent mass of A with respect to weight of B with respect to equivalent mass of B. So according to the question, 1.6, and this would be 8. This is your silver. So weight of silver by atomic weight 10. So cross multiply it and you will be obtaining weight of silver. You can cancel this directly. 826.2. What is 0.2 of 108? It would be roughly 21.6 grams. Option number D is the answer to question number 41. Option D is the answer to question 41. It's clear, right? So let's see question number 42. It's the match the column type question. So you have to find the correct matching for question number 42. Correct matching would be, yes, resistance. This is incorrectly matched, right? This is correctly matched. This is also correctly matched. Simon meter inverse was correct. G is wrong. It is not. Okay. So 42.3 means D only. D only is the answer to question number 42. 43. 1 Faraday of electricity is passed through molten alumina, aqueous solution of copper sulfate and molten sodium chloride taken in 3 different electrolytic cells connected in series. The molar ratio of aluminum, copper, and sodium at the respective cathode is. So the charge carried by 1 mole of electron is 1 Faraday. Thus, this. Okay, let me simplify this. Okay, when this metal ion gain electron, it undergoes reduction. So how many Faraday? N Faraday for 1 mole of this M. Now for aluminium, you're going to require 3, copper 2, iron 1. So the ratio would be, it should become 1 by 3. Okay, we are considering aluminium, copper 1 by 2, 1 is to 1 for sodium. So get the simplest whole number ratio, it would be 2 is to 3 is to 6. 236 is the answer for question number 43. Question number 44. If rho is the resistance in ohm of a centimeter cube, generally called the specific resistance of the substance constituting the conductor, the resistance R of the layer containing A cube is given by. So 44, reciprocal of resistance is what? Conductance, right? So we can add the conductance and not the resistance. And hence, 1 by R would be equals to 1 by rho, etc. Whatever up to the limit given to you. So 44 would be A is the answer to question number 44. Okay, I hope it is understood. And as usual, you try answering the last question. This is left for you. Read the question, take the screenshot, and answer the question in the comment section. Thank you for joining up till now, and keep studying. Happy learning, and we shall meet in the next episode. Thank you.